In this example, we're given two operational amplifiers. This is the first one and this is the second one, and they're connected in such a way that the output of one is connected to the output of the other, and they're connected using a resistor in here, and I'm being asked to figure out the value of the current flowing through this resistor. And you should be able to recognize by now that this particular, actually both of them are connected in an inverting configuration. So you'll see that the positive is connected to ground, and then there's a feedback loop from the output to the input in here. So that will be my R2, that will be my R1, and that will be the input source. And this is the same, and that will be my R2, that will be my R1, and it's also connected to the inverting, so both of them should be inverting. However, you should also pay attention to the fact that this 150 milliohm, the negative is connected here as opposed to the positive in here. So what we need to do in order for us to figure out what the current flowing through these is to figure out the voltages across it. So for example, I can just say this is V output 1 and this here is V output 2. All I have to do is figure out V output 1 and V output 2 and just take the difference between them, and so that we can figure out what the current is. So let's get started. So I'll figure out what V output 1 is. V output 1 is simply R2 divided by R1, negative R2. Okay, let me just write it. V output is typically negative R2 divided by R1 times the V input, and that's basically for an inverting amplifier. Okay, so that's what I'm doing right now, which is negative 47 kilo ohm divided by 10 kilo ohm times 1 volts, and that basically will be the value of V naught. And we can write it in terms of that. Let me just do that here. So let me just do this here, and let me just call this one here as VS1, and this one here is VS2. And the reason why I'm doing this is because in the second one, I'm being also asked to, well, let's change the VS2, okay, which is the left source, so that this current is 0. So I'll just write these equations in VS1 and VS2 just so that when we come back to it, I don't have to rewrite them. So this becomes in terms of VS1, which is at this particular moment is negative 47 divided by 10 times 1 volt, which is negative 4.7 volt. That's exactly how much this output value is in here. So let's do the same thing for V output 2. So V output 2 will be negative R2, and that will be negative 220 kilo ohm divided by 33 kilo ohms. And in this particular case, my V input, that will be VS2, okay, which is simply negative 220 divided by 33, and the VS2 happened to be negative 150 millivolts, because the way that the polarities are flipped, so this particular source is actually flipped. All right, and that will give me the following value, which is exactly 1 volt. All right, so now we have this voltage, we should be able to figure out what IA is. IA is simply, I believe it's V output 2 minus V output 1 divided by 1 kilo ohm, and that will becomes 1 minus 4.7 divided by 1, which is simply 5.7 milliamp. Okay, so now we know this particular one is done. So now the second question is being, we're asked, well, what if I were able to change the value of VS2? What value would make that VS2 result in an IA that is 0? Pretty much I'm asking you what value would make the voltage difference between these here is 0. So let's double check in here. So what we're being asked to do is to do the following. So we're looking for an I of A, which is equal to 0, to be equal V output 2, okay? Let me just write it one more time in here. So IA, we write it as VO2 minus VO1 divided by 1, which is just simply VO2 minus VO1. Okay, so now we wrote V output 2 and V output 1 in terms of VS1 and VS2, so I'll just substitute them here. So that will give me V output 2 is simply negative 220 divided by 33, and that will be VS2 minus plus 47 divided by 10, because minus VS1, okay, and that's IA. So now what value of that particular VS would result in a 0? in a 0 I of A. So let's do this here. So we'll do 0 in here, and that equals negative 220 divided by 33 of VS2, okay? And because the VS2, we have to pay attention to the negative and positive and whatnot, but let's keep it at this for now, VS2, plus 47 divided by 10, and the value of VS1, I'm not being asked to change it, so I'm just going to keep it at 1. So that's one equation, one unknown, so let's find what the value of VS2 is. And the value we get is exactly 705 millivolts in here. Okay, so that's plus 705, but that assumes that VS is actually this way, plus minus VS2. Okay, I did not incorporate the negative in here. So if you take a look at that VS2 in here, I incorporated that it's negative. Okay, I put the negative in here. In here, what I did, basically I assumed that the voltage is, let me just highlight it in red so that you remember it. I assumed that the VS2 is that way, and what I've done is whenever I use VS2, I just substituted, well, I wanted the opposite originally, negative 150. But for the rest of the equations, VS2 is still that red one in here. And the value we got is 705 millivolt, okay? So that means you have to connect the VS2 this way with a positive on the top, the negative at the bottom. And if you put it, it's exactly 705 millivolts, you'll get the I0 to be 0.